One part of studying right angles deals with trigonometric ratios or trigonometric functions. So the trigonometric ratios, mainly we start teaching them with right angle triangles. But before we start introducing the ratios, you first need to know how to label the triangles. So with these questions, you're always going to be given a right angle triangle and an angle in there. So what you need to know is how to label this triangle before you even start with any calculation. So when I'm given, for example, this right angle triangle, first identify your hypotenuse. So this is my hypotenuse opposite the right angle. And then identify the angle you're looking at. So usually they'll label it, or they'll tell you by a letter, or they'll give the number in there. So this, by the diagram, this is the angle I'm looking at. So you want to label something called the opposite length. So this is the opposite length. And you also want to label the adjacent length. And what adjacent means, it just means next to it. So the length next to this angle is here. Now the reason you label the hypotenuse first is because this length is also adjacent to the angle, but the hypotenuse is unique. So just make sure that you label the hypotenuse first. Similarly here, this is the hypotenuse. This will be the opposite this time, and this will be the adjacent. So the adjacent and opposite alternate depending on where your angle is. So you have to be careful when you're labeling your triangle that you're identifying the correct angle and you're correctly looking at the opposite and the adjacent. So now that we know how to label the triangle, let's look at the trigonometric ratios. So these are the ratios, and what they precisely mean is that you can go into more depth with how are these true and why are they true, but basically they identify that the ratio of the lengths together are equivalent for different angles. So when we see those relationships with different angles and lengths, we can use this property that we discovered and just use it to help us find different angles and lengths. So this is what we use the trigonometric ratios for, to find missing angles and missing lengths. But first we have this relationship. So we first have the sine ratio, and the sine, all of the trigonometric ratios take the angle as their argument. So sine theta, cos theta, tan theta. And the ratio of sine is basically the opposite length divided by the hypotenuse. The cosine ratio is the adjacent divided by hypotenuse, and the tan ratio is the opposite divided by the adjacent. And as you can see here, I just took the example where the angle is on the top and I labeled my triangle. So if you have an angle given here, then the sine of that angle, you can just use your calculator for that, is going to be exactly equal to the opposite divided by the hypotenuse. And that's what we mean by ratio. So using these properties, if one part is missing of this ratio, we can find it. So that's where they're useful. An acronym to use to memorize all of these steps is the SOH-CAH-TOA, and remember it's going to be sine equals to opposite divided by hypotenuse, cos is equal to adjacent divided by hypotenuse, and tan is equal to opposite divided by adjacent. So you just need to remember those, how the ratios work. So examples, if we look at an example about finding the missing length. So what I would recommend is always writing the SOH-CAH-TOA on the side so you know which one you want to use. So this question requires us to find the length x. Again, first label your triangle. So we have the hypotenuse here, we have the opposites here, and we have the adjacent. So whenever you want to find the missing length, first tick the things you have. So we have the angle, which is usually attached with the ratios. We then have the hypotenuse, okay? Now, as you can see, I have the hypotenuse, which means, and it's not in the tan ratio, so I won't need to use the tan. And next, what do you actually need? So what you're gonna take are the things that you need to take two things that you have and then identify one thing that you need. You need the opposite, so this is the thing you need. So we're gonna end up using the sine. If you use cos, it won't be useful. You don't really need the adjacent, you need the opposite. So you always want two known things and then one unknown. So if I take the sine, so this is sine 30 because my angle is 30 equals to the opposite divided by the hypotenuse. So I'll just substitute what I have. I have the hypotenuse as 8. And then what you're going to do is cross multiply. So this is over 1. And then what you're going to do is just cross multiply. So you have sine 30 times 8, and then x times 1, and then that will just give you 4 centimeters. And that's the final answer. So pretty easy to use. Ideally, if you had the adjacent, then you'd use the Pythagoras theorem, but in the cases where you don't and you just have the angle, then you just use the trigonometric ratio. So that's when they become handy. Another example, let's label this triangle as well. So I have my hypotenuse, I have the adjacent, and I have the opposite. So similarly here, I'm going to see, well, I have the angle here, and I have the adjacent, and what I'm missing is the hypotenuse. So that's the length that I need, which means I'll have to use the cos. So if I just write out the cos ratio and then substitute what I have, so notice here that the unknown is in the denominator this time, and what you can do is still cross multiply. Also, just be comfortable with algebraic manipulation here. You can cross multiply, so you end up with x cos 30 equals to 65, and then you have to divide by cos 30 on both sides. So you get x equals to 65 divided by cos 30. That's one way to do it, or you can, if in an illegal wording, you can just say, oh, swap the cos 30 with the x. So that's why you get 65 by cos 30, and that's equal to 75. Make sure whenever you're doing these that your calculator is set to degrees, unless you're dealing with radians. What if we are missing angles? So in the case that you're missing angles, we're going to follow the exact same thing, but we're going to do one extra step with the ratios. So again, label your triangle. This is my hypotenuse, this is the opposite, and this is the adjacent. And what you're going to do is, again, identify which ones you need. So obviously we need all the angles, so these won't be missing. I have the opposite, and I have the adjacent. So the one which has 2 ticks and a question mark is my tan. So I'm going to use the tan in this case. Again, lay out the tan. So tan theta is equal to opposite over adjacent. Substitute the values you have. And what we're going to do is something called the inverse function. So there's the sine, cos, and tan are functions. We can't just divide by tan on both sides because they are functions. They have inputs and outputs. So that's not how you deal with them. In order to undo the tan, or to kind of do the whole move it to the other side and change it, what we do is something called tan inverse, or the trigonometric function inverse. And this you can find in your calculator by pressing shift and then the button of the trig function itself. So once we do that, what you're going to get is tan inverse, so that's the notation, of 5 divided by 8, and that's going to give you 32 degrees. Again, make sure that your calculator is set to radians, to degrees if you're dealing with degrees. So that's how you do it. So you don't divide by tan. There's nothing such as divide by tan. What you do is tan inverse. So that's when you want to find the angle. So every time you want to find the angle, it's always a tan inverse. So another example, again, we're going to label first. So we have the hypotenuse, we have the adjacent here, that's next to the theta, and then we have the opposite. So we're missing the angle, and we have the adjacent, so I'm going to tick the adjacent. We also have the hypotenuse, and the only one with 2 ticks and a question mark is the cos. So I'm going to do the same thing. So cos theta is equal to adjacent over hypotenuse, and substitute the values that I have. Make sure you substitute correctly. And then I'm going to do the exact same thing. I'm going to take cos inverse of the right-hand side. So cos inverse of 3 over 6.5. Remember, what you want to do is find theta. So in order to isolate theta, you have to remove the cos. And the only way you could do that is by taking cos inverse. So by doing that, I'll get 62.5 degrees, and that's rounded to 3 significant figures. Hopefully this was clear. There are other videos in the channel that go into more in depth with trigonometric ratios, and they have more solved examples in there if you need more practice, but this is kind of a quick summary on how to do it.